Hi guys, we're finally going to tackle these trig identities. So you can see here I have a list broken up into the categories of the different identities. And what we're going to do with these identities, we're going to simplify trig expressions, and then we're going to verify trig identities. Now I could go through and prove why all of these are true. We just don't have the time in the video to go through and do that. I can highlight some things just so it makes sense. Obviously sine and cosecant is the reciprocal of sine, so that it makes sense that sine theta will be 1 over cosecant theta, which is a reciprocal. You got tan theta is equal to sine over cosine. Well, tangent is equal to y over x. Sine is y, cosine is x, so that makes sense. Of course, the reciprocal here. You got your Pythagorean identities. Understand that this right here, sine squared theta plus cosine squared theta equals 1. I can use this to derive all of these. So you could either know just this and then derive all of these, or you can memorize this, this, and these, this one right here, and then of course just by manipulating, if I subtract cosine squared theta over to this side, I have this identity. If I subtract sine squared theta over to the side, I have this identity. And you can do the same over here, just a matter of preference. And then the last grouping that you probably can't see till I scroll this up, you got your cofunction identities and your even odd identities. So again, we're going to use all of these to simplify a trig expression or to verify trig identities. And I'm going to go through that process with you. So let's go ahead and take a look at the first example. And so you can see that we're going to simplify trig expressions first. And I even broke this down a little bit further, saying that the ones that we do in the beginning are going to involve factoring, so that you can see that it'll help as we're going through. So when you look at the first one here, you got cosecant squared x minus cotangent x minus 3. Well, that kind of looks like a trinomial that we could actually factor, which we're going to do that. The only thing is we got two different trig functions. So we want those trig functions to be the same. So then what you would start doing is looking at some of the trig identities and say, is there any way that I can get these to be the same trig function? So if you look at your trig identities, you would see that cosecant squared x is equal to 1 plus cotangent squared x, one of your Pythagorean identities. So if I go ahead and replace cosecant squared x with 1 plus cotangent squared x, I would then have the same trig function in my expression. So let's go ahead and do that. So I'm going to take this and put it in here, and that's going to give me 1 plus cotangent squared x minus cotan x minus 3. So then we look and see if we can simplify anything from here. I can go and combine the 1 and the minus 3, so that would give me cotangent squared x minus cotangent x minus 2. So now, when I do this with the students, sometimes I'll say you can do like a substitution. So basically, you can go off to the side and you can say that I'm going to allow x to equal cotangent x, and then go ahead and replace that. So this would look like x squared minus x minus 2. Some students find it easier to factor this way than having the trig functions involved in here. It doesn't really make a difference. So if I do this little substitution here, and then I factor x squared minus x minus 2, that is going to give me x minus 2 times x plus 1. And then you can go ahead and replace your x with cotangent x, so you would get cotangent x minus 2 times cotangent x plus 1, and then that is simplified by factoring right here. Now understand, you don't have to do this step in here by doing the substitution. You can go right from here to the factoring if you're familiar with it. Just again, some students like to see it as a trinomial with that variable, and then they just replace it. It's totally up to you. So let's look at another one here. So let's say that we have tan squared x minus tan squared x sine squared x. So you could be thinking, all right, well, maybe I can just try to change this here into a sine and a cosine, but that's just going to add something different. But remember, right now we're in the category of factoring. So if you look, I got a tan squared here, and then minus, there's a tan squared in this term right here. So what I could do is take out a common factor of tan squared x. So if I factor out a tan squared x, what does that leave me with? So I have it here, I factored it out, that means it's 1 minus, I factored it out here, that's sine squared x. So then like, all right, well, how does that help me? I still have a tan and I have a sine. Well, think about your trig identities. So you have cosine squared x plus sine squared x is equal to 1. If I manipulate that, then cosine squared x is equal to 1 minus sine squared x. Just by starting with my identity, cosine squared x plus sine squared x is equal to 1, subtract the sine squared x over, and I get this right here. So I can go ahead and replace this with the 1 minus sine squared x. So then that would give me tan squared x times cosine squared x. So now you're saying, well, I have a different trig function, but I made this a little bit smaller because I had a 1 minus. Now I just have a single term for my trig function. Well, you can even go further than this, because if you look at cosine squared x, and then you got tangent squared x, if you look at your quotient identities, tan x is equal to sine over cosine. Well, that also means if you square it, it would be true in the same way. Tan squared x is equal to sine squared x over cosine squared x. So I can go ahead and say that this here, I'm going to replace it with sine squared x over cosine squared x. I still have times cosine squared x. And now hopefully you can see that this right here, you multiply, those are going to reduce out, and it gives me sine squared x. All right, let's take a look at number 3. All right, so looking at number 3, you can see we get the negative sine squared x minus cosine x minus 5. So again, it looks like that trinomial that we want to factor, but we got the two different trig functions. So what can we do? Well, we know that sine squared x, if we do some manipulating with the Pythagorean identity, is equal to 1 minus cosine squared x. So if I replaced this with 1 minus cosine squared x, then I'll have the same trig function. Just be careful with the minus in the front. So when I write this, I got negative 1 minus cosine squared x, because I have the negative in the front, then I'm replacing sine squared x, and then I have the minus cosine x minus 5. So then we want to go ahead and distribute this minus sign. So negative 1 plus cosine squared x minus cosine x minus 5, combining like terms. So that gives us cosine squared x minus cosine x minus 6. So now again, you can do the substitution saying that x is equal to cosine, so you get that trinomial, and then factor the trinomial that way. So again, if you did the substitution, it would look like x squared minus x minus 6, and then when you go ahead and factor that, that would give you x minus 3 times x plus 2. Or you could just go ahead and factor right from here, and that would give you the cosine x minus 3 times cosine x plus 2. Either way works. All right, so let's take a look at number 4. So we have sine to the 4th x minus cosine to the 4th x. So now looking at this, hopefully you recognize the difference of squares. So these two are both perfect squares. So in other words, it would look something like x to the 4th minus y to the 4th. So if you were to factor that, that would go ahead and give you x squared minus y squared times x squared plus y squared. So let's go ahead and do that substitution and plug these in here. So if I do that and factor with the difference of squares with my trig functions, that would give me sine squared x minus cosine squared x times sine squared x plus cosine squared x. And then when you're looking at what you got here, hopefully you see this right there and say, oh, well, sine squared x plus cosine squared x is equal to 1. So I can literally replace that with 1. So if I do that, you get sine squared x minus cosine squared x times 1. Well, what happens if you multiply anything times 1? You're just going to get itself. So that's just going to give me sine squared x minus cosine squared x. And then you might think, all right, well, I'm pretty much finished. Well, remember, here you still have two terms in a subtraction. So you have to check to see if you have the difference of squares, and you actually have the difference of squares again. This looks like x squared minus y squared if you were to do a substitution, which of course would factor to x minus y times x plus y. So again, if we go ahead and do the difference of squares, plugging in our trig functions, that's going to give us sine x minus cosine x times sine x plus cosine x. And then that would go ahead and be factored all the way to the end. So let's take a look at the last factoring problem, number 5. So what we have is sine x times cosine squared x minus sine x. So looking at this here, we got a sine x here and a sine x here, so hopefully you're thinking common factor. So I can go ahead and take out that common factor of sine x, and that would leave me with cosine squared x minus 1. So now when you're looking here, you might be thinking, oh, I got my Pythagorean identity. I know that sine squared x plus cosine squared x is equal to 1. And then I can go ahead and subtract this over to the other side. So I get sine squared x is equal to 1 minus cosine squared x. But then you look and you say, well, that's actually not the same. It's just completely different in terms of the signs. The signs are opposite. Well, what if I factor out a negative over here? So if I factor out a negative, it just changes the signs. So if I do that, factor out a negative, that makes that negative sine x, and it changes all of these signs. So now this becomes a positive 1, and this becomes minus cosine squared x. Now I have the same thing that I need, so I can replace this sine squared x for the 1 minus cosine squared x. I can go ahead and replace that, and it gives me negative sine x times sine squared x, and then when I go ahead and multiply that out, it gives me negative sine to the third x. And that is simplified. So we're going to go ahead and take a look at some other simplifying problems that really don't involve necessarily factoring, but involve everything else and some of the other identities. So we'll take a look at that in the next part.